We want to look at this question related to the Solow model, where we do have populational labor growth, but we don't have technological progress. So we're given two countries, and we're told they have an identical production function, but there are different savings rate, population or labor growth rates, and different depreciation rates. And this results in different levels of steady state output per worker. And we want to use the Solow growth model along with the well labeled diagram to explain why the steady state output per worker is different for the two countries. So we're given two economies. Now they have identical production function that we're told over here. Assume the two countries have an identical production function. So we have identical production function. We have they both have different delta. The depreciation rate in country is 1.5%, in country B 3.5%, so in country B it is higher. They have different N. N represents your labor or population growth rate, which is higher in country A, and we have different S. And the savings rate is higher in country B. Right, so savings rate is higher in country B. So now what we want to do is, so now let's see, and we want to now compare, let's compare both of them, right? So we have A and B. Let's write it here. So we have A here and we have B here. So let's first compare investment per worker in both countries. Remember what investment per worker is? Investment per worker is found as SFK, and FK is your output per worker, which is a function of capital per worker, or per worker production function that is identical for both of them. Right, so they have an identical production function. Now for country A, the savings rate is given to us as 0.1, so it's 0.1 FK. For country B, the savings rate is 20%, so it's 0.2 FK. So country B has higher investment per worker curve, has a high investment per worker curve. When I plot the investment per worker curve for country B's investment per worker curve is higher because it's 0.2 FK, and for A 0.1 FK, right? So country B has higher investment per worker curve. So now I want to compare a break-even level of investment per worker for both of the countries. And we know in this case, break-even level of investment per worker in the Solow model, where we do have population labor growth, but no technological progress, is given to us as N plus delta. So it's break-even level of investment per worker. So it's N plus delta K, right? N is your population labor growth rate, delta is your depreciation rate. Now, for country A, N is given to us as the population labor growth rate is 0.06, plus the depreciation rate is given to us as 0.015. So this is given to us as 0.075K. For country B, the population labor growth rate is given to us as 0.1%, that is 0.001, plus we're given the depreciation rate is 0.035 plus 0.035. So this is times K. So this is just basically going to be 0.036K. So country A has higher break-even investment per worker line. So country A's break investment per worker line is higher. For country B, it's 0.036K. For country A, it's 0.075K, right? So country A has a higher break-even, because in our Solow diagram, we have the production function, right, which is identical for both of them. We have the investment per worker curve, which is higher for country B. We have the break-even level of investment per worker line, which is higher for country A. Now has a high break-even investment per worker line. So now if we plot it, so we're just going to keep this in mind. Let's plot it now. Let's just erase this and let's plot it now, keeping in mind K Okay, so if we plot it now, right? So let's plot it. So we know on the vertical axis we're taking output per worker, on the horizontal axis we're taking capital per worker, right? So let's first make their break investment per worker lines, right? Let's make for country B using grid. We know country A has high break investment per worker line, so this is for country B. I'm making this for country B, and then using grid to making for country, and country A has a higher break even investment per worker line, like we just discussed. So sorry, so this is for country A. The break investment per worker line is 0.075K. And this is for country B, the break investment per worker line, which is 0.036K, right? And now we know the investment per worker curve we said is higher for country B, right? So I'm going to make country B's investment. I'm sorry, this looks really bad. Let's try to make it a little lower like this. This makes sense. Right, so this is for country B. The investment per worker curve is 0.2 FK. Now let's try to make it for country A. Country A's investment per worker curve is lower. So this is for country A. And this is 0.1 FK. So let's find this steady state level of output and capital per worker for both of them. For country A, remember graphically, the steady state level of capital per worker is given by the intersection of your investment per worker curve and your break-even investment per worker line. So this is the investment per worker curve for country A. This is the break investment per worker line for country A. So the intersection gives us the steady state level of capital per worker for country A. And then we know they have an identical production function, right? So that identical production function we can show as this, right? Fk. This is identical. The per worker production function is identical for them. Identical per worker production function, right? That's identical for them. So this is the identical per worker production function, right? It will be above both 0.2 Fk and 0.1 Fk because these are translated down versions of this. So for country A, from this per worker production function, we can see okay, this is Y star. Now let's do the same for country B. Country B is So we know country B's steady state capital per worker is given at the intersection of its investment per worker curve, which is this, and its break investment per worker line. So this is K star B. And then using that identical per worker production function, we can find its steady state level of output per worker. And as we can see, this is given to us as 2.56, and this is given to us as 1.89, and we can clearly see the difference, right? So we have explained why in the two countries. So we're shown that given the differences in the population growth rate, savings rate, appreciation rate, steady state level, basically graphically we showed that that translates into higher investment per worker curve for country B and a higher break investment per worker line for country A. So as seen in the graph, so then that translates into that K star B steady state capital per worker is greater than for steady state capital per worker is greater for country B than country A. And so steady state output per worker is also greater for country B than country A. Right, so explain the difference in the steady state level of output per worker. We explained why for country B it is higher. Because basically, essentially, because of these differences in the savings rate, population rate, and depreciation rate, B's investment per worker curve was higher and its break-even investment per worker line was lower. So the key takeaway here is Solow model can help explain level differences. So we're explaining level differences, right? Differences in the level of steady state output per worker level differences. By level differences, we're talking about the level of steady state output per worker. We're not talking about growth rates. Level differences between countries, level differences in countries in levels of income that could be persistent over time. In levels of income, in levels of income, level of countries, in levels of income that can be persistent over time, right? So explaining level differences in levels of income, that would be persistent over time based on different structural parameters, right? That could be persistent over time based on different structural parameters, right? And by structural parameters, we mean the savings rate, the depreciation rate, and the population labor growth rate, right? So we're using the Solow model to help explain level differences between countries. By level differences between countries, we mean in levels of income that could be persistent over time, and this is based on different structural parameters. We're given these differences between them, we help this to explain that why the steady state level of output workers higher in country B than country A.